Hi! In many problems, in many situations, we can see the problem of direct, inverse, or joint variation problems. And today we're going to explore a different method the method that you can see in many books, that is using the equation. I'm not saying that it's wrong, we're just going to explore another method, and after you see the table option method, so you can choose which one is the best for you. Okay, so remember just that the direct variation is when two variables are related by the equation y equals k times x, and remember that the inverse variation is when two variables are related as k over x. Okay, so in this case, every time that x increases, so y increases, and in this case, every time x increases, y decreases. Okay, and the joint variation situations is when we have three variables, one in which we can say c, it's a constant, times x or y, and we don't know the power of x or y because it depends on the relationship. So could be this form, like z equals kx over y, or z equals kxy, or could be z equals ky over x. Okay, depending if it's direct variation between x and z, or an inverse between y and z, or the other options. Okay, so the main situation, or the way that we can see in many books of how to solve these problems is to find k in any situation, to find k, and after you find k, you just have to use the equation with k to find the answer. But here we're going to change a little bit using a table and see how could work without finding k. So we're going to see three examples, and I hope that with these three examples the method is clear and you can use it every time you need it, and every time you have a problem that involves direct, inverse, or joint variation. So let's see the first question. The first question says y varies directly as x when x equals 32, y equals 6. Find x when y equals 10. So what I'm going to do is that I'm going to do a table of x and y, and I know that when x is 32, so y is going to be 6, right? And it's telling me that we need to know what is x when y is 10. Okay, when y is 10. So look at that, what we're doing here is just organizing on a table, and to find x, what I'm going to do is this method. The unknown variable with x, I'm gonna set in with a positive sign, and what I'm going to do is to check if it's direct or inverse variation. So look at that, here is a direct variation. So what means that if y is increasing, then it means that y increases, x increases. So, or if x is increased, y increase. Okay, if x increases, y increases. So I'm going to put a positive sign that shows me that relationship, and this I'm going to write negative because it's decreasing in this direction. I'm going from negative to positive, and the answer is as simple as multiplying all the positive numbers that denotes increasing. So 10 times 32 over 6, so that's gonna give me 6 divided to 3, 10 divided to 5, and we have here 5 times 32 divided 3, 5 times 2, 10, 5 times 10, 5 times 3, 15, 1, 16. Okay, so x is going to be 160 thirds. So that is just, let's do the division by 3. So this is 5, 1, 3, 53 and 1. So 53 and 1/3. Okay, 53 and 1/3. Okay, so what we have here is x using the direct variation situation is in a table. So remember what we did. We notice that when x increases, as is directly as x, so y increases, and we set positive signs to denote or to show that is an increase situation. Let's see the same example with an inverse variation problem to see how it works. So it says that y varies inversely as the square of z when y equals 6, z equals 4, find y when z equals 3. So what we're going to do is the same. Is the same thing. So we have z and this is y, and when y equals 6 the variation is with the square of z. So what we're going to write is the square of z, so 16. Okay, 4 to the second power. And we wanted to know z when we're going to know z when y equals we're going to find y when z equals 3, but is the square of z, so 3 to the second power, 9. Okay, but in this case this is an inverse variation. So always the number that is opposite on the same column that the unknown is going to be the positive, because it represents the same term that we're going to multiply. And in this case it's an inverse variation, so it means that if y increases, what's going to happen to z? Z is going to decrease. So we're going to put a negative that denotes decrease and a positive that denotes increase. So the answer would be y equals 16 times 6 over 9. Okay, now let's reduce this expression. So let's divide by 3. 16 times 2, 32 thirds. So what we have as an answer is that y is 32 thirds. That is 10 and 2/3. Okay, y equals 10 and 2/3. That is pretty cool because it's obviously greater than 6 because we increase z. Okay, so I hope that you're getting the information, that you get what I'm doing with the table, because we're going to pass to joint variation situations. Okay, so here we have y varies directly as x and inversely as the square of z. Find x when y equals 10 and z equals 6. Okay, so take a few minutes, if you like, pause the video to propose using the table the solution. Okay, now we're going to see the answer. So I hope that you pause the video and propose the solution. So let's see the answer. We're going to do the table, but in this case we have 3 variables. The first variable is y, the other is x, and the other is z. The order is not important. What is important is what is going to happen to the variation. So it says that okay, here I forgot to write the first part. That is, when x equals 6, y equals 2, and z equals 5. No, find x when y equals 10 and z equals 6. Okay, I'm sorry, I forgot the first part. So now we're going to shoot the table. So now it's time to pause the video. Pause the video and do it. Now we're going to see how to do it. So when x equals 6, z equals 5, and y equals 2. Okay, and what we need to find x. So by following our instructions of the table, this is positive, and y is 2 is 10, and z is 6. But remember that y varies directly as x and inversely as the square of z. So we're not going to work 5, but the square of 5, 25, and the square of 6, that is 36. Okay? Remember the word, the square of z. Now, we know that when y increases, z increases. So I know that if y increases, x increases, and z decreases. Okay, this is what we know according to the information of directly as x and inversely as the square of z. But here is the thing, what happens if the one that increases is x? What's gonna happen? So if x increases, I'm gonna use blue. If x increases, what is gonna happen if z is a constant is that y is going to increase. Okay? Because y increases with x. But what happens if I want to have y as a constant? If x increases, to have the same proportion, and y will be constant, so z needs to increase as well. Got it? For example, if y is 2 and x is 4 and z is 2, okay, if x increases to be 6, means that z should be 3 to have the same division, so z increases. Okay, so to solve the situation we need to follow the blue increasing or decreasing, the blue variation. So here, as x increases, y increases, and as x increases, keeping y as a constant, z increases. Okay, so now what we're going to do is to multiply all the positive numbers. So we have 10 times 36 times 6 over 2 times 25. Okay, and now we just have to simplify the expression. So 2 divided to 1, 6 divided to 3, the fifth part of 25 is 5, the fifth part of 10 is 2. Okay, and there's nothing else to simplify. We have here 36 times 6, 30 times 2 is 6, divided 5. So we just need to write that. 6 times 6, 36. 6 times 3, 18, and 3, 21. So 21, 216 over 5. Okay, and that's the answer. That's how you find x using both inverse and direct variation situations, I mean a joint variation situation, by using a table. Okay, obviously if you feel comfortable using the equation, you can solve it as well using the equation. Check it and let me know if it's right, and tell me which one of the methods you prefer. So I hope that you enjoyed this video. I hope that you have an excellent day using direct and inverse variation problems, and tell me if you have any comments, like and subscribe, and see you in the next video. Remember that all my social network are Hugo Fim. So see you, and I hope that you enjoy this video. Bye.